problem, I need to find the tangent and the normal line at the point P, pi over 4, pi over 2 for this curve. So we've got to remember that the derivative is equal to the slope of the tangent line, which is equal to the rate of change. All the same thing. So in order to find the equation of the tangent line at this particular point, well, I already have the point. If I want to use the point-slope method of the equation, I need to find the slope, which means I need to find the derivative of this curve. Well, it's not a nicey-nicey y equals x kind of a curve. So I'm going to do it by implicit differentiation. And I'm going to take the derivative of that side and the derivative with respect to x of this side. And that's the way I'm going to find the derivative. Well, noticing that both sides of these are products. So I'm going to have to use the product rule, which is u prime v plus u v prime. So let's work on the left side. Well, I have u, which is u prime, so x prime is just simply 1. And then times the derivative times v, which is sine 2y, plus u, which is x, times the derivative of v. Well, I'm looking for the derivative of this. Well, the derivative of that is going to be cosine 2y. And since I have to use the chain rule, it's going to be times 2 times the derivative of y with respect to x. That's going to give me my left side. And that is equal to, I'm going to go on my right side. Well, I'm going to find u prime, so the derivative of y is derivative of y with respect to x, times cosine 2x, plus y, that's my u right there, times the derivative of cosine 2x. So that's going to be times the derivative of cosine is negative sine 2x, but I got to do the inside part, so that would be times 2. So, kind of simplifying this out a little bit, I have sine of 2y plus x cosine 2y times 2 dy dx is equal to, well, I have a negative sign and a 2, so I'm going to go negative 2y sine 2x plus cosine 2x dy dx. So now let's get everything with the derivative, the dy dx on one side of the equation. So I'm going to start with this right here, and I'm going to move this 2 just to the front, just to make it look a little bit easier. So I have 2x cosine 2y dy dx. And then I'm going to subtract this from both sides. So I have minus cosine 2x dy dx is equal to, well, I'm going to subtract this from both sides. So I have minus sine 2y minus 2y, it's right here, sine 2x. So I have all my dy dx's on one side. So I'm going to factor it out, and I have dy dx times 2x cosine 2y minus cosine 2x is equal to negative sine 2y minus 2y sine 2x. And now doing some division. I have all by itself now the derivative of y with respect to x is equal to, I'm going to divide both sides by that, so it's going to be negative sine 2y minus 2y sine 2x divided by 2x cosine 2y minus cosine 2x. So that's my derivative. And if you remember, I'm looking for the tangent at this particular point right here. So my x values are going to be pi over 4, and my y values are going to be pi over 2. Well, I think I can do that. I'm going to say the derivative at my point P is equal to, let me look again, pi over 4, pi over 2. So I have pi over 4, comma, pi over 2. So I have negative sine 2 times pi over 2 minus 2 times pi over 2 times sine 2 times pi over 4 divided by 2 times pi over 4 times cosine 2 pi over 2 minus cosine 2 times pi over 4. Let's see if we get an answer here. So that's equal to negative sine of pi, 3's canceling out, minus pi times sine, the 2 and the 4 cancel out, pi over 2. Divided by, well, 2 times pi over 4 is pi over 2 times cosine pi minus cosine pi over 2. So the sine of pi, looking at the unit circle, the sine of pi, well, that's 0. So that's negative 0 minus, well, pi, the sine of pi over 2 is 1. And that's divided by pi over 2. Cosine of pi is negative 1 minus the cosine of pi over 2. Cosine of pi over 2 is 0. So I have on my top, I have negative pi divided by, well, this looks like it's equal to negative pi over 2. And simplifying, I multiply both sides by negative 2, the top and the bottom, not both sides, by the reciprocal, negative 2 over pi, so that cancels out. My pi's cancel out, my negative signs become a positive, and it turns out my slope at that spot right there is 2. Wasn't that fun? So now we need to find the equation of the tangent and the normal lines. which shouldn't be that hard since now I know the slope, and I still have my point, which is pi over 4 pi over 2. The point is pi over 4 comma pi over 2. And using the point slope form of the equation, the tangent is going to be y minus, well, let's divide it here, y minus y1 is equal to m times x minus x1. So I have y minus pi over 2 is equal to 2, our slope, times x minus pi over 4. And the only big difference with the normal line has to do with the slope. If I have a slope of 2, the normal line slope is going to be the negative reciprocal, so negative 1/2. So I have y minus pi over 2 is equal to negative 1/2 x minus pi over 4. That's the normal line. And so finally, I'm going to check my work on Desmos. And I just graphed this relation here. And man, it is really exciting to look at, isn't it? I'm going to change my settings so that my x-axis isn't I want to make my x-axis in steps of, let's say, I want to make them in steps of pi over 4. So the step is going to be pi divided by 4. So I can kind of see a little bit better what it looks like. And so it gave me the pi numbers there. And I'm going to put in my tangent and normal lines. And my tangent line, the blue one, is definitely looking tangent right there at pi over 4. It doesn't quite look perpendicular. So I'm just going to see if I can't get it back to a... Actually, I'm wrong. In fact, it does look perpendicular. It didn't look perpendicular because I was looking at it at my computer screen, and up on the screen where it's where you can see it, where you're looking at it, does look perpendicular. So I'm pretty satisfied with my answer to this problem.